This Week in Radio Tech, episode 305, is brought to you by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. By Zipstream, sponsor of Streaming University from the Telos Alliance, 14 video lessons in high-quality audio streaming. And by the Axia Radius AOIP audio console. It's a standalone console that also networks. Spend less and get more with Axia Radius. What if you could transmit 15 radio program channels from one FM transmitter and receive them on existing FM HD radios? Philipp Schmid, research engineer at Nautel, has been demonstrating exactly that. How does it work, and why might a broadcaster want to do this? Philipp joins Chris Tobin and Kirk Harnack to explain. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. I'm delighted to be here. We've got a real treat today, something I've been wanting to learn about for a long time. I first saw this a little over a year ago at the NAB show in 2015, and we're going to bring it to you today. You want to know what it is? Well, hang on. This is the show where we talk about everything about radio engineering, from the microphone to the light bulb at the top of the tower. Hey, Chris Tobin normally is along with us, and he should be joining us in just a little bit late. I know he's interested in this technology too, so he'll be along just as soon as he can. Our show is brought to you by three fine sponsors. We'll get to them in just a minute. A quick note here before we bring our guest in, and that is this interesting microphone. I did a little review of this mic, and I don't know, I think we're all enamored with when we find something really inexpensive that does the job, that seems to work okay. And I can't vouch for the quality behind this microphone. I have no idea about its internals or how long it might last, or if the gold paint is going to peel off in the next few days. But I got to tell you, this condenser mic cost all of $14 and then $5 shipping. And it's not bad. I've compared it with this mic. Now, this is a $1,000 Sennheiser microphone, an MKH416. It's very popular among voiceover artists. And this is the mic that I use for audiobook recording, general narration, for recording things for Telos. And I love it. It does sound amazing. But I can tell you, this little $14 microphone isn't bad either. So I thought I'd do the show today with the $14 microphone. It's going through a DBX 286S audio processor, mic processor, and then via Skype on its way to you. By the time it gets to you, it's been coded and decoded and encoded a couple or three times. But anyway, we'll see how it goes. So. Also wanted to mention a couple of program notes before we get into today's show entirely. Coming up next week, I will be absent, but Chris Tobin will be here. And our guest, you can't wait to hear from this guy. It's Charlie Wooten. Now, Charlie has been elected by his peers in past years as the Engineer of the Year for Clear Channel before it became iHeart. Charlie Wooten has been on our show before. He's a heck of a good engineer and a great guy. And if you keep up with him on Facebook, he knows where to eat. He knows where the fine food is. He's always able to find it or cook it himself. And so he'll be our guest on next week's show. We'll be talking about the Dayton Hamvention. He was there, and some of his other exploits in the past few weeks and months having to do with radio engineering. So you ought to check out Chris Tobin and Charlie Wooten coming up next week. Also coming up in the next couple of months, my goodness, I have been busy and really lucky in scheduling some awesome guests over the next few weeks. If you don't mind, just bear with me here while I give you a couple of examples. Well, I thought I could, but of course the calendar I'm looking for doesn't appear to be here. Tell you what, I'll bring that up a little bit later on. I know we've got some amazing guests coming up later this month, later in June and in July as well. So, hey, it's a good place to be. Put this on your subscribe list, This Week in Radio Tech. It's available for subscription from a lot of your favorite podcast aggregators, and it's on YouTube as well as the usual GFQ network. So there we go. All right, let's jump right into it now. And before we get to a commercial, I want to bring in our guest, and that is Philipp Schmid from Nautel. Philipp, welcome in. Hello.
Yes, hello. I'm pleased to be here today.
Man, it's great to see you. Kind of in person. I've seen you at the Telos booth. At the Nautel booth at the shows, but we haven't gotten a chance to talk very long. And you have got some amazing technology. Why don't you give us a little tease about what we're going to see right after the commercial break?
Yeah, exactly. Well, certainly NAB is always a busy time, so we can't always get in touch with everybody there. It always flies by. But some of the cool demos we've shown over the last 2 years now is termed HD Multiplex, and we'll actually have a live demo on the show here. We'll show you all the audio channels we can actually produce, and hopefully patch it all through the system here, so you can actually get a live demo, even though maybe you haven't made it out to NAB. So you haven't missed anything then.
And what's amazing about this technology, and this what the last thing I want to tease with, it works with HD radios that are for sale on the market today. This does not take special gear on the listener's part. Am I right about that?
Well, that's exactly right. Like, this might still be a little bit out in the future, but it could happen very, very quickly because the receivers can already do it today. So we don't have the chicken and the egg problem with some of the other schemes that are out there. This could work today.
That's cool. We're going to be hearing more about that on This Week in Radio Tech. It's HD Multiplex, and Nautel has been working on this and figuring it out. So we'll get with Philip in just a minute. Hey, let's talk about our first sponsor, Lavo. And I really appreciate Lavo and their crystal clear audio console sponsoring our show This Week in Radio Tech. Everywhere you go these days, you're finding touchscreens. I just bought a Google Pixel C, and it's like a big cell phone, but it's actually fairly effective. I can get a lot of work done on this thing, and it's a touchscreen. Of course, the big Google Pixel computer is a touchscreen, but more than that, there's a touchscreen on your smartphone, your tablet. Supermarket checkouts have got them now. Yes, I want to start. Yes, here's what the bananas price code is. Laptops are coming with them now. Radios in your car have them. Even airplane cockpits are having touchscreens nowadays. Well, they make sense because when they work nicely, when they're well designed, they are simple and very natural to use. Their intuitive controls help you finish tasks faster and with fewer errors. Isn't it time you brought the power of touch to your radio studio? Well, you can with the Crystal Clear Virtual Radio Console from Lavo. Crystal Clear gives talent an instantly understandable multi-touch interface. Faders, meters, clocks, timers, talkback, and more live in harmony on a single screen, so shows are running smoother and sounding better. Crystal Clear features Lavo's exclusive Auto Mix. Now, that's the hands-free, smart mixing algorithm designed for fast-paced multi-mic talk shows. It's kind of automatic. And Auto Gain. Just push a button and the preamp calibrates automatically while your guest is speaking in the mic. So you don't overdrive the mic pre or underdrive it. Now with that advanced automation, talent can even dock the mixing controls and use their screen to do other things. They can work with delivery systems, audio editors, phones, things like that. Crystal Clear's power plant is just 1 RU. Now that's pretty amazing when you consider the staggering amount of DSP on board. Compression, EQ, voice processing, precision delay, they can all be applied to your mic, line, and digital sources. Optional upgrades include redundant power, MADI, and Ravenna AES67. And all of this power costs really no more than you'd spend for an ordinary console. So if you're thinking of a new console, don't decide before you check out Crystal Clear from Lavo. Go to www.lavo.com. That's spelled LAWO.com, and read about it. Or call Bill Bennett at Lavo USA, if you're in the USA. He's at 888-810-4468. That's 888-810-4468 to find out more from Bill Bennett. So the future is clear. It is Lavo Crystal Clear. Thanks to Lavo for sponsoring This Week in Radio Tech. All right, jumping right into it. Philipp Schmid, a research engineer at Nautel. I love this about Nautel, that Nautel takes the time, energy, and money to put into research and hires people like Philipp to say, okay, what's next? What is coming up? How can our technology help with the whole radio broadcasting thing as time goes forward, and what can we do with it? So, Philipp, why don't you kind of give us a little overview of what you're talking about here with HD Multiplex?
Well, exactly. Yeah, with me, you never know what kind of curveballs you're going to get next. So this is one thing we thought about last year, and it was in response to some broadcasters approaching us, looking forward down the road. The hybrid FM plus HD revolution, more or less, is on its way. But let's think about a future where we have no more FM carrier. Assume we could turn off the FM. What could we do? And at the time, we really didn't have any solutions per se. So some of the ideas we had been thinking about in the past is what is if you could broadcast multiple HD signals out of a transmitter. So I'll show you a little bit of our test setup here.
Hey, I'll tell you what, but before we really jump into that, now I'm reasonably familiar with HD, and I know that stations already transmit their FM carrier and an HD1, which is a simulcast, and then you can have an HD2, an HD3. I'm not sure about if people are doing more than that, but so we're already doing some degree of multicasting on there. But you're talking about a whole jump in the level of the number of stations or audio channels that you're carrying.
Right, exactly. Today you can get up. HD4 is fairly common. We've got a number of stations that do broadcast HD4, so they've got a total of 4 streams. But the one thing that we showed at NAB last year is that we were able to squeeze in a 5th one. Now, certainly, there's trade-offs with that. You've got, so many bits on air, and, whichever way you slice and dice them, there is trade-offs with that. But the interesting thing is you've got various audio configurations that really help you here. You've got the full stereo mode that works quite well down to about 32 kilobits. And, of course, that requires appropriate pre-processing. It's a little bit different than your typical FM processing. You want to make sure that your audio coder doesn't waste any bits on unnecessary information. Things like your 60 hertz microphone hum doesn't need to be there. Background noise needs to be filtered out. Things like that really a codec struggles with need to be removed. But stereo works quite well down to 32 kilobits.
I'm glad you mentioned this taking care of the audio before it goes into a really low bitrate coder. Now, I'll wave the flag here and say that, the company I work for, Telos, the Telos Alliance, we've actually been researching this since the mid-90s about how to make low bitrate codecs more efficient. So I'm sure, if not during this show, we've talked about this on previous shows, and Telos has a lot of information online about this very subject. What do you need to do to the audio? How do you process it so that at a low bit rate, it doesn't sound so watery, it doesn't sound so mucky and muddy, that it doesn't have these weird artifacts. It actually sounds very listenable and clean. So I just wanted to point that out, that what you said about prepping that audio for a low bitrate codec is really, really important, more so than if you've got a high bitrate codec. Shoot, if you're encoding at 128 kilobits per second, well, you don't need a lot of treatment. It's going to sound pretty good. But if you're encoding at 32 kilobits, you need to be very careful about the audio that you're feeding into there and treat that really right. So I just wanted to jump that in with that because it is important. So what happens after the audio processing in your system?
Well, that's exactly right. But even without the processing, Ubiquity now, DTS, has done perceptual listening in the past, and they figured out at what point listeners can discern the difference between the bit rates. And even without much processing, they found that below, I think it was about 40 kilobits per second, even sound engineers couldn't really statistically tell the difference between higher and lower bit rates, whatnot. So, stereo at 32 kilobits is very doable today. If you have more bits available, go up to 40, 48 if you like. But beyond that, there's really no real need. Some people might disagree with that, but certainly that is a bit of an opinion. But then the other options, the other modes that you have available to you, if you want to squeeze more audio into lower bit rates, you can get into parametric stereo. And parametric stereo, it provides you a stereo effect, but in essence, it's a mono transmission with some steering information. And that gets you fairly good audio down into the 24, even 20 kilobits per second. So that works quite well at even lower channel bandwidths, and it still gives you somewhat of a stereo effect. Now, if you do an A-B comparison between full stereo and parametric stereo, you'll hear the difference. But if you just listen to it, it sounds pretty good. Then, of course, if you only have a mono stream, well, you can get mono down to 16 kilobits or even lower if you have to. We can really get more audio streams into our HD system.
So I want to ask you about something you just said, parametric stereo, and I'm familiar with parametric stereo because it's part of HEAAC V2. So, and that's a codec that's common on the public internet for streaming. But I did not realize that a parametric stereo implementation was available in HD radio. Do I understand that right?
I'm not the expert in that, so I can just tell you what I know about it, certainly. But my understanding is that it is somewhat of a precursor to that. It's been around longer, certainly. Our product supports the parametric stereo. And the exporter, you can set mono parametric stereo or full stereo. And the same thing on the importer for all your multicast channels. Same configurations exist there, too.
Okay, cool. I'm glad that it's available in the HD implementation.
Exactly. So when we showed 5 audio streams on our standard GV10 transmitter at NAB last year, we actually turned quite a few heads because a lot of people didn't know that was even possible. It was actually quite interesting that even some of our folks in the industry came around that should have known better. But wow, what are you doing here?
Now, was that 5 in addition to the FM analog, or was that without the FM analog?
Well, the first one is the simulcast, of course. So the FM and then 5 digital streams. So
gotcha.
I guess the total is 6. If you could separate FM and HD1, then yes, you would have 6.
Okay.
Right.
All right.
So we can put quite a few audio streams in there, and more and more stations are building out on multicast. If you look at New York City today, you've got 122 HD streams. So the build out is happening. That's a long ways from, let's say, the 30 stations we might have had 10, 15 years ago. Now you got 122 listening choices in places. So it's really happening. The other thing too to consider is more and more cars out there are equipped with HD radio receivers. In New York City, we're exceeding 20% now. Same with Miami and various other markets. So the rollout is happening. So I think we're at the right time now. Now that this hybrid FM plus HD rollout is happening, now is the time to really start thinking about an all-digital future. I'm not saying that this will happen overnight, but we need to think a few years out. So here is one of our solutions that we're thinking could address that particular issue.
And this is just exactly the right time. It turns out Chris Tobin is available. He just came online. So, hey, Chris, welcome in. We're talking with Philipp Schmid from Nautel.
So I hear. Great, welcome.
And you came at just the right time because we were kind of just bringing ourselves and everybody right up to the current state where FM stations, are transmitting, their analog, the HD1, and then up to as many as 4, even Nautel has shown 5 more programs in stereo on HD, on additional HD channels. And we were just about to get into I think an all HD world here is where Philip may have been going next. So you came in at just the right time. By the way, how you doing?
I'm doing well, thanks. Sorry for the delay.
Oh, no, I know you have problems to solve. And hey, next week you're going to be here all by your lonesome with Charlie Wooten. So
yes, that should be fun. I have some good questions.
Hey, I love Charlie to death. If you ask him a question, he can just talk for the whole hour. It'd be fine.
No problem. Well, I'll make sure we have control of the microphone.
Okay. All right, Philip, you were about to explain more HD digital, so carry on, please.
Right, yeah, I was just mentioning we have 122 HD streams in New York City, so Chris can probably attest to that. Some of those are unique, only available on HD radio streams, and what we find is that particularly if stations put unique content on their HD, people will listen to it. And we have stations that get more calls on the HD dropping out if the transmitter drops out and whatnot than on their FM in some markets. So, it really attests to the fact that HD is moving, finally. So, looking towards the all-digital future here, what I've brought with me here today is we have one of our transmitters running here in the corner. So we've got a 300-watt VS300. The HD exciter sitting down here that's spitting out the signal. Now, what I'm showing you today is still a bit of a, let's call it a science experiment. It's not product. Don't expect to, buy this at this time or anything like that. But we want to show that we can create the signal, amplify it, run it through a real transmitter, and I think this has a real chance of making it happen. And, here it is. So the basic concept is, like I said before, we've been approached to see about what if we turn the FM off? What are our options? Well, right now, if you just turn the FM off, you just have a big hole. You have, essentially you'd have those outer 2 carriers here. The FM would sort of sit in the middle here. If you turn that off, you're just left with these 2 carriers.
Okay.
Well, that's not, we've wasted bandwidth. That's really not a good solution per se. Now, years ago, there has been a proposal, or it's already in the NRC standards as such, to fill in the inner carriers with lower level called secondary carriers. The problem with that approach is, first, well, it's not implemented in receivers at this point. So we're starting the whole chicken and the egg thing over again. There might be a few, I don't think it's in any receivers as far as I know. And the second thing, too, is it doesn't really make sense to broadcast those middle center carriers at a lower power level, because you've got your channel. That's, it's your channel that's been granted to you. Why would you reduce the power in it? It doesn't make sense from an allocation point of view. It doesn't make sense from, the whole FM planning point of view. So our solution here is a little bit different. So what we've done is, we'll maintain the center 2 carriers here that you see on the screen, but we frequency shift 2 separately modulated HD signals that come from separate XGens, separate exporters, separate importers, parallel transmissions chains, call it. And we frequency shifted them 100 kilohertz one way and 100 kilohertz the other way. So now we have 3 interleaved stations. Each one of them can have 5 independent audio streams on them. And the key is that once you combine these signals, once you add them together, the problem with that is your peak power requirements in the amplifier suddenly go up. Let's say, assume you had 3 FM signals and you frequency shifted them, added them together. A single FM signal has constant envelope. It's frequency modulated, so the envelope is constant. Once you add 2 or 3 together, they start to intermodulate with one another and create peaks.
Right.
So the channel combiner guys can tell you that. The antenna guys can tell you that, because they have to figure out what those peak voltages are across their antenna system once you add all these FM signals together. So the same thing is true for HD as well. So you can't just shift and add. So what we're bringing to the table, Nautel was the first manufacturer to really latch onto hybrid crest factor reduction, peak to average power reduction.
Yeah.
Where we said we really have to consider both the FM and the HD in the power levels going through the transmitter. Well, this is kind of the same thing, except now you have multiple HD signals going through at the same time. So you really need to do crest factor reduction of the combined system. And we found there's a few caveats when you have to do that. A few technical things, like there's phase shifts that happen on the shifted frequencies that you have to account for. So we had to modify the standard way of how you do peak power reduction to fit this scheme. But it's the sort of thing that we do. That's the sort of thing we're good at. So we're very excited about this. Now, right now, this system here is essentially playing out vectors. So I've created all this in MATLAB and I'm playing all this stuff through. But to make this a real-time implementation wouldn't be all that difficult to do. We just haven't had time to do it yet. So maybe the best thing is let's just show the demo as such now that you have an understanding of what it all does. So we've got 5 audio streams across all 5 of these. So the other thing that I have up here, you have just an off-the-shelf Insignia receiver that works perfectly fine. It's off-the-shelf. I didn't make any modifications to it. And for our demo here, I'm feeding the signal into a Sangean tabletop receiver that goes into our mixing board. So hopefully we'll be able to patch the audio right through to you. But keep in mind, don't judge the audio quality here, with all the transmission schemes and podcasting and all the encoding and re-encoding and transcoding that's going to happen here. Don't judge the audio quality. It's just to demonstrate that we can actually show you 15 audio streams on a standard off-the-shelf receiver. And at the show, at the NAB show, I had a Sony receiver. So there's at least 3 models there that work perfectly fine with that. One thing just to highlight on the receivers, they do require European tuning. A lot of receivers do. And with European tuning, I mean you have to tune in 100 kilohertz steps, because we shifted these frequencies by 100 kilohertz. Now, in this case, we'll tune in at 87.5, 87.6, and 87.7. So that is the requirement on the receiver, that it provides European tuning. Now, we don't have to be at 87. I'm going to get into why it chose that frequency in a little bit here. But it would work across the band, of course. But you do have to be able to tune in 100 kilohertz steps. Mm-hmm. Which is not every receiver does do that, but certainly most chipsets do.
Yeah,
so,
okay, all right.
Let's fire up the transmitter here. We're only running at about 60 watts here. And Should be coming up there shortly. There we go. And as our pre-correction kicks in, you can see that it's starting to repress some of the regrowth on the side here. So overall, we don't have a mask clearance definition at this point. So, we can't say we're that much under the mask or anything like that. But I feel comfortable that, we can take this signal and we can make this work. Even though it is now wider than the standard signal, we can run it through our transmitters. I think we can make that happen. Not only that, I think in the future we can build this concept out further. We could even have a 1 megahertz wide signal, a 1.2 megahertz wide signal. Like you can just piece on more stations as you need.
Okay.
So,
all right.
Let's see how we go here. So the only thing about this demo, because it is a cyclical, it's just a vector that loops about every minute or so. We might hit a patch in the middle where the receiver will drop and then reacquire, just because it's skipping back in time.
And by the way, for our TWiRT listeners who are not viewing the show but listening to the show, as actually typically in podcasts, there are more people listen than watch. What Philipp is showing us right now on the screen, he's got a PC screen there showing a spectrum analysis display. Where is this being generated? Is this coming from your Nautel exciter itself or somewhere else?
Yes, exactly. It's our advanced user interface, the AUI, as we call it. And it actually shows you the spectrum that the transmitter is producing at the output. So we actually have a built-in spectrum analyzer right there, and that's what I'm looking at. And
so we're looking at
six
kind of
HD.
Yes. Okay. Six carriers. Each one is rather tall and kind of pillar looking. Not like a hill like an FM transmission would be, where it typically is centered around the middle and then the sides drop off. But these are your HD carriers. So if you've ever seen a spectrograph of two HD carriers, one on either side of an FM carrier, well, the FM carrier is gone here, and we're looking at a total of 6 of these pillars of HD modulation.
That's exactly right. And the other thing too is, unlike FM, that is a pyramid shape, and the spectrum really extends quite a ways. We've got sharp transitions here to the next channel spacing. That's another benefit of HD. It's got a very well-defined spectral occupancy. So let's get to the demo and tune into some of those channels. So right now we're tuned to 87.5, and you should start to hear some of the music that's there now at 87.5. And as we then now tune through, we go to 87.5-2 HD2. And that one is at 24 kilobit. The first one was 32. We're at 3, 4, 5. And as we go to 87.6, you'll hear some static. Now the receiver's acquiring a new frequency. And it should start to play now again. Now we're tuned to the center carriers right here at 87.6. Then we move up to 87.6-2, HD2, 3. So we're now at channel 8, channel 9, channel 10. And now we'll go to 87.7. And again, because it's still a hybrid service mode, that's what it's called. It's still trying to play the non-existent FM. That's why the hiss is there at first. But then it's tuned in back to channel 11 at 32. Channel 12 is 24, 24. And I think one of them is mono at 16. And the last one is 24 again. So here we go. I think we've listened to all 15 audio streams. I hope they made it through okay. I can't actually listen to it here.
Yes, we heard them.
I hope you could hear them all there. So there we go. 15 audio streams out of one transmitter, one antenna, one transmission site. And really, we need to start thinking about the applications that we can do with this sort of thing. It's really revolutionary, but we need to think about what the possibilities could be.
And that is a perfect segue, because we're going to chit chat for a second here, and then take a break for another sponsor. Chris, Tobin, let me get your thoughts on this, right now, and then when we return from the ad, maybe you can ask some more questions about the applications or how you see this getting used. If there's already 122 HD channels in New York, do we really need to multiply that by 5 or so? Uh-oh, can't hear Chris.
Try this again. Since I came in late, I have to ask the one question. those multiple carriers, is that on the one allocation, say the FM 87.5, the 200 kilohertz slot?
Well, what we're looking at here is a 600 kilohertz occupation. So
Gotcha.
that is one thing that we do need to figure out exactly how we can work that in, and I'll work into that in the applications. Now, one thing that we can do is we can drop off the outer carriers. As a matter of fact, I can show you. If you have a minute there, I can certainly bring that up real quick. Let me see if I can just change my demo here. And I can show you a 400 kilohertz mode. If I bring that up again. And in this mode, I've simply dropped off the outer sidebands. So now we're into 400 kilohertz, which is really no different than your 200 kilohertz FM plus HD today. So that, this mode would fit into your standard allocations, no problem. Now we just replaced your FM power with HD power, which goes a lot further. 1 watt of FM, well, or I should say 1 watt of IBOC is about equivalent of 10 watts of FM, depending on how you look at this. Now, the only caveat with that is now a receiver will have to operate on a single sideband only. If you tune into 87.7, it will only run on one sideband. But there's enough forward air correction in the signal to be able to do that. And I can even demonstrate that, if you would like, that you can actually tune into 87.7 with one sideband, but not all receivers like that. There's definitely a signal degradation there. There's research going on right now to actually come up with proper single sideband modes. And once those are in there, I think this will be a very realistic mode. So that would fit in quite nicely. But even if you go back to the 600 kilohertz mode, the 600 kilohertz mode, I would argue, still can fit into our allocations. Think about it this way. Let's say you've got a short-spaced station, so you're limited in transmission power, and let's say you only got 1 kilowatt of FM, and you're already hybrid at -10. What if you converted the 1 kilowatt of FM into HD? Well, before we do that, you're already broadcasting 2 sidebands on the side here with HD. You're already into your first adjacent at that point. In-band on channel is really in-band adjacent channel because you're on your first adjacent. But you're only halfway on your first adjacent. So what if you dropped your iBox sidebands on the outside by 3 dB and converted that power to more carriers on the outside? Really, there should be no more interference to your first adjacent than it was before. So I would argue you could probably even make the case that a 600 kilohertz allocation can work in today's systems as well. But I'll get into that a little bit more in a couple different applications later.
Okay. Just curious, in the 400 kilohertz mode that you were showing, how many audio channels would a broadcaster have?
Well, again, it's the same signal configuration, so I could still show you 15 audio streams. The problem is that a single sideband just won't go as far.
Right, I understand.
You've taken away the power, you've taken away the frequency diversity of the 2 sidebands, so your coverage has been reduced, but not your audio capacity.
Right. Okay. Gotcha. I came in late. That's why I just wanted to ask. I may be repeating something you've already said, but I just wanted to make sure I understood. That was my understanding of one of your presentations of this technology once before. So I just want to make sure I was on target. Okay. Great. Perfect. Right. Thank you.
Good. Hey, and I'm glad you asked. That's what I wanted to know too. What kind of spectral bandwidth does this take? And I understand where Phil's going with this. We could live in a world where 600 kilohertz of occupied bandwidth is the norm, and still get along with everybody. Hey, you are watching or listening to This Week in Radio Tech, episode number 305. Our guest is a very smart man, and I love the stuff that he's showing us. Philipp Schmid from Nautel. And he's talking about HD multiplex, a way to get many audio programs into an all HD world. No analog carrier, but all HD. And this is pretty darn interesting. And this is just the beginning of things. I got to imagine that as we go forward, and Phil can address this as we do, that this could become more convenient. Could end up being a one-box solution. At the transmitter end for the encoding, just could be very cool. Might be a way to get different languages on different programs. But we'll talk about the applications coming up. Hey, our show, This Week in Radio Tech, is brought to you by the folks at Zipstream, it's a division of the Telos Alliance. Zipstream is really working hard to help you get your streaming on the air, on the internet. Could be over the air if it's done by mobile, by Wi-Fi, because the internet is, by golly, just about everywhere, and broadcasters need to be able to get their audio, their content, the stuff they've worked so hard to produce, get it to listeners any way the listener wants to take it. And if it's not over the air as a standard FM channel, hey, maybe a good way to do that is over the internet. Now, I know a lot of stations are streaming right now, but are you really doing it well? Does it really sound good? Is it what somebody would want to listen to day in and day out, or for hours at a time, as long as you can keep them listening to your station? Well, the folks at Zipstream at the Telos Alliance are really here to help out. Now, here's how. There is now a series, a whole 14-part series on YouTube. You can access it from the Telos Alliance website. You can go straight to YouTube, to the Telos Alliance channel, and look up Streaming University. Streaming University. And we'll put the link to this in the show notes, but you can also find it just by going there. There's a look right there. There's 14 different lessons in Streaming University. Hey, I'm your professor. Yes, you can bring me an apple. And there won't be a test at the end of it, but the real test will be, how successful are you at streaming high-quality audio over the internet and making that high-quality audio available in, say, several different coding algorithms, several different bit rates, so that listeners can listen no matter where they are and what kind of device that they have. Streaming University, it's a project that we've really been working on for actually close to 3 years altogether. In the last few months, it's come together, and 14 videos are now produced, beginning with, hey, just let's all get on the same page about how streaming works. And then we have a whole chapter about codecs and algorithms and bit rates, and how do you need to prepare your audio for a bit rate reduced codec. And then we have chapters on CDNs, that is content distribution networks. We have chapters on how you get this stuff out to the listener the best with either MP3 or AAC. How do you configure an adaptive multi-rate stream using, say, Apple HLS? There's a whole chapter on that. What about metadata? How do you get metadata into your encoder or to your CDN? How can you use scheduling if you have an internet broadcast that only happens, let's say, Mondays at 5 p.m. Maybe it's a city council meeting. So you can turn on a stream on and off automatically, for example. Just all these different aspects of streaming that, hey, we as engineers, we need to understand this stuff. We need to be able to go back to our management, to our programmers and station owners, and have a really good clue as to how this works and how to do it right. I was very pleased to work with a lot of other people at the Telos Alliance and some other CDNs and other experts in the streaming and internet distribution industry to bring you this 14-chapter series. So let me implore you to check this out, learn what's in here. You can, follow along at your own pace. As I said, there's not a test later. The test really comes down to, are you successful with streaming, and are you doing the best job possible for your stations and getting them on the internet and making them easy to find and easy to listen to? So Streaming University, you can find out more about it at the Telos Alliance website, or, hey, just go to YouTube and search for Streaming University, and it should pop up there pretty quickly, this 14-chapter series about how it all works. I had a great time putting it together, and I think you'll have a pretty good time watching it. I've talked to a few people who said, hey, watch the whole thing. I said, wow, did you fall asleep? Hope not. Streaming University from the Telos Alliance. Thanks a lot to Telos Alliance for sponsoring This Week in Radio Tech. And by the way, the concepts that you learn about audio processing for streaming are 100% applicable to the kind of digital audio that we're talking about here on this TWiRT show with Philipp Schmid. So let's reintroduce everybody. Chris Tobin is here with us. He is, Chris, where are you? Are you in New Jersey today?
Yes, I'm in a studio in New Jersey. This is a voice booth I'm in right now. I was just helping out doing some stuff, and things got a little out of hand. So I just quickly ran in, dropped the laptop down, and here I am. So,
well, a voice booth seems like the right place since you are using that.
Yes. So hey, I have a real quick question. Oh, yeah, go ahead. Yeah. So good.
Well, and I wanted to reintroduce our guest. Philipp Schmid from Nautel is here, and he is a research engineer, and I love that title. I'm so delighted that Nautel, and I know some other companies too, take the time to hire people to simply do research. What technologies do we know about, or can we learn about, that will help the broadcast industry and broadcasters to do their job? So, Philip, glad you're here. And so, Chris, what was your question you wanted to pose?
A quick question. I'm doing a lot of work with an engineering firm here in the metro area, doing a lot of RF work, microwave linking, spread spectrum, the whole bit, co-FDM and whatnot. Does the technology you're talking about and the crest factoring and everything else regarding the digital modulation, would that fall under power complementary cumulative distribution functions and those waveforms and signals? Just curious.
Yes, right. I think you're touching on something called a CCDF, the complementary distribution function. Exactly. And what that is simply a statistical overview of how often a signal exceeds a certain power level. And that's sort of the tool that we use a lot to get the intermittent peaks, mostly the ones that happen very infrequently, down to very low levels. And a lot of spectrum analyzers give you that function today. We actually have a tool. I could probably show you that right on our transmitter here, since you asked.
Yeah, this is amazing, this advanced user interface. This is great because you can just bring up all kinds of intelligent things about the transmitter.
Exactly.
Oh, yeah, absolutely. I maintain two Nautel NV10s, and I use the AUI all the time for stuff. It's great. It's a well thought out form factor and design. I have to applaud Nautel for that.
So here you're actually looking at the CCDF function of the signal we're broadcasting, and it actually brings up a number of good points here. So what that is if you click on anywhere on the curve here, you see right now we're at 5.4 dB above the average power level. So you can see how peaky the signal is. And what you can see is we've got a very sharp drop off at around that 5 dB, 5.5 dB power level. And that is due to our crest factor reduction. So that is the tool that we use to really get that low, to be able to bump up the average power in our transmitter and get more power out of the system for you. And that's really what that is.
Philip, let me see if I can restate this, because this is a problem that I have understood briefly in my life. It seemed you mentioned earlier that when you mix these digital signals together, you end up sometimes when they add constructively, and you can get really the need to transmit a really peaky signal. So your average level may be here, but you have peaks of valuable information that are way up here that take many, many, many more watts of power from the transmitter to push out. And crest factor reduction is kind of like the digital RF version of audio peak reduction, where you mitigate these pieces of data to where you have a smaller crest factor. Now, I've explained it how I understand it. Tell me where I'm wrong and kind of fix me up with a better explanation.
Yeah, I think the analogy to audio processing is actually very close, and it's the same kind of purpose. If you reduce the peaks, then you can bump up the average. You can become louder. You have more transmission power. So it's the same kind of concept. So I think the analogy to audio processing is quite true. The difference is, of course, in audio processing, we're trying to work with our human ear, and we're trying to work with our various engineering specifications, modulation error ratio and spectral emissions masks and that sort of thing. But I think the analogy is quite there. And the interesting thing is, with all these intermodulating carriers, what you're actually broadcasting through your transmitter, if you don't do anything to it, it's actually a signal that looks like white noise. That's really what it looks like. Band-limited white noise.
So this crest factor reduction, and this is I take it this is a mathematical algorithm that Nautel has worked on. Is that right? Is this an industry-wide HD radio, or is this a Nautel exclusive sort of thing?
Well, we're the first ones to sort of experiment with hybrid crest factor reduction, where we take the FM carrier into account. But even the early HD systems, they needed to do some crest factor reduction, because if you don't do anything to that, you'll have a signal that's like 12 dB in power. So if you want to broadcast 1 kilowatt, you need like a 20 kilowatt transmitter or something like that to get that on the air. So in order to become more economical, there was already a crest factor reduction in place. We just made it better.
Gotcha. Okay, so this it gets rid of. Does it get rid of the peaks, or does it move the data around just a smidge so that it mixes in better?
We're still on air here, but I've lost your feed. Hopefully, you can still hear me there.
We're still hearing you just fine. Yeah.
Oh.
So we're still hearing Philip just fine, but looks like they're going to try to reset that. So Chris Tobin, while they're resetting that, can you tell me your thinking about crest factor reduction? I'm trying to help folks who don't do HD radio, or maybe who do, but really not quite sure how it's working inside, what that feature is and what it does for them. How does it help them transmit better HD radio?
Well, I guess the best way to look at it is, and this is the reason why I was asking about the CDDF, because I've been doing some work with an engineering firm that's been doing some digital wireless linking, and crest factoring has come into conversation. But what happens in the digital world is you have peak energies above what we normally operate with, and as a result, they have to be controlled. And that's what the crest factoring in the very broad strokes is trying to do. And I was asking this question because if we go in this direction of digital and looking to do more with digital, whether it be HD or whatever, these are things we have to understand as engineers and understand how spectrum analyzer, how to use it, and what to look for. Otherwise, as Philip pointed out, 1 dB or what did he say, 12 dB. You're talking 20 kilowatts to put out a 1 kilowatt signal. The ratio is what you have to control. And just like you pointed out with the audio and limiting, we're doing the same thing in RF. And it's done with cellular systems. Right now, the 4G cellular systems, if you go to a cellular site, if you have the opportunity and know somebody who'll let you in and they'll actually talk to you, if you get to meet one of the RF guys, they will talk to you about how they're multiplexing multiple digital carriers to create a cell site. And the amount of filtering, I'll call it, and the what I like to say, waveform shaping that takes place at a cell site is phenomenal. And the HD that we're talking about just touches the surface. It's that's where things are going. This approach that Philip's talking about it reminds me of Eureka 147 back in the day when we were talking about doing digital DAB, having one site with multiple carriers for everybody to be on.
So I guess anytime that you're mixing multiple carriers together, you end up with this problem, right? Where you might end up with peaks that to transmit properly, you got to have a transmitter much bigger than what is normally required for the average, right?
Right. It's not, and remember, this is not a negative thing. This is not like a bad thing. This is the laws of physics at play. So you have to understand how to manage them. Take, for instance, a master antenna system. You're an urban center. You're building. You have a tower that has multiple transmitters on it. Say here in New York City, we have the Empire State Building. You've got Fort Times Square. You've got a few other places, and now you have all these FM stations going into a combiner, and they're also doing HD. Well, this is a combination of what we've been doing for years. The manufacturer of the antenna system, the combiner and the antennas, has to factor in the peak energies. Even though we're all running, say, 10 kilowatts each because of our heights and who knows what, you still have to factor in the peak. You're doing HD plus the analog, you have to factor in the peak when you're designing the antenna. So it's not like it's suddenly new. It's something we've just come across. It's been around for a while. It's just now more pronounced because we're adding more and you can do more with the digital. As Philip pointed out, you've got those 6 carriers and you've got 15 channels of audio. There's a lot of RF energy going on. So once you understand the principles and see what's going on in that world and understanding how a spectrum analyzer, in the case of the advanced user interface, you get to realize, wow, you can do a lot. It's just managing it.
But by the way, we're working to get Phil back on. We appear to have a computer problem at the studio, so we're working to get that back on. Suncast is working on that. But Phil's explained a lot of the key concepts here, and I think Chris, you and I can go ahead and talk about some of the applications while we're working to get Phil back on. I want to understand a little bit better about. I'm sorry to keep harping on this crest factor. You made the analogy to multiple analog FM transmitters operating into a master antenna, and so I guess there are going to be times when several of those signals combine at just the right point in time. It's going to happen, on a random but mathematically, frequent basis, to where you've got to build in, a big enough system to where peak voltages, won't arc over the antenna system or the coax. Am I getting that part of it right?
Yeah, that's pretty much it. I mean, that's part of it. It's basically it's in the, let's see, how do you do this? It's the peak to average ratios that take place in the RF signal in the case of digital and analog. So it's at varying levels. So I think as Philip pointed out, was it 1 dB or 1%? And there's 7.5 dB of increase. Yeah, it's a ratio. It's basically you're dealing with a ratio. So when you can manage the crest or manage the peak to average. I'm using my fingers as a high-low type thing for those visually impaired on the podcast. That's what you're trying to control. Otherwise, you'd have a runaway. Think of it like the Nyquist theorem, right? You can't have anything more than the frequency sample divided by 2. Otherwise, you violate the Nyquist law. So it's similar in crest factoring and in transmission, multiple carriers, and in the digital world, you have the ability to go beyond what you see as an average, and the peak to average has to be controlled. I'm trying to avoid the crazy, physics that get into this whole thing.
Well, when you have 2, 3, 4, 10 FM transmitters being combined together and they're analog signals, there's nothing mathematically that you can do to avoid this. You've got to build your combining system and the stuff downstream from that big enough to handle the occasional times when these come together. With HD radio, you do have the opportunity to predict when these big peaks will occur, and in software through algorithms, you have the ability to mitigate that. And I think that's one thing that Nautel did early on with their in-streamer and X-streamer. Their coder that people were having to use IP pipes between studio and transmitter that were much bigger than they needed. Because of these occasional spikes. And Nautel came up with some algorithms to minimize this to where you needed an IP pipe only a little bit bigger than what you would need as an average. So I think that same idea also applies to the RF transmission.
Yes.
Anyways, that sound about right?
Yeah, that's about right. Yeah.
So we're still working to get Phil back on. He seems to have no internet. Maybe I thought there was a problem at the studio. Maybe on his end, he's offering to Skype in on phone only. So we'll see if we can get him back. In the meantime, Chris, at the NAB show, I was talking with some engineers from Nautel to see what could happen, how this would get used. How would you use 15 channels? So let's say that you live in a culturally diverse community. I mean, here in Nashville, Tennessee, we don't have a lot of diversity. You got some, but there are whole populations here in Nashville that are unserved in their native tongue. I mean, there's a lot of folks from Ethiopia living here in Nashville. There's a lot of folks from Mexico living here in Nashville. My next door neighbor is from Venezuela. So, there's people who would love to hear audio programming in their native tongue. And so being able to put more channels on the air fairly inexpensively, would allow that kind of niche programming to be on in digital quality.
Right. However, you have to find an allocation slot that's available so you can put up this carrier and have the choices for those folks. If you're in a market that has no empty slots.
Yes, what I was understanding was, now they can do a smaller version of this in 400 kilohertz, a standard FM. I mean, if it fit under the FM mask, but if an existing FM station right now, and I don't know if it's legal yet, you might have to get some kind of STA, but if an existing FM station said we're going to turn off our FM carrier and go with a bunch of HD programming, then they can program out. We'll need to ask Phil how many that could be, but it's more than 4, it's more than 5 that they can do just with what they already have at reasonable bit rates that produce audio that's listenable. Hey Phil, are you back with us, sir?
Yes, can you hear me? I'm back on my cell phone now.
It's kind of the audio's a bit distorted and torn up, but it kind of sounds like cell phone audio.
Oh, okay. I guess that's what we'll have to deal with. But yes, your discussion on multiple audio streams is very pertinent.
Actually,
one application.
You talked to us about if an existing FM station, getting whatever permission that they need to, wants to take up no more spectral bandwidth than they do now, but turn off their FM carrier and be all HD carriers, what can they expect in terms of the number of programs they could run?
Right, exactly. So essentially, I showed you that mode of running in 400 kilohertz on our transmitter there. And like you mentioned earlier, if you turn one of the sidebands off, what you're losing is not bits on air, but forward air correction. So it doesn't really reduce your total band capacity. You could still have the same number of audio streams, but your signal won't go as far. So
Right.
not only have you lost half of your power with the other sideband, but you've also lost your frequency diversity. So the signal won't go as far. That's really your caveat. It's not that you've lost number of audio streams, but you've lost the ability to your coverage area. That's what's been impacted there. So we could have still the same number of audio.
I'm sorry. Say the last thing again.
You can still have the same number of audio streams per se. It's just that they won't all go as far. So the
okay.
Right. But the one thing that I think people want to look at is if you look at your own station, and if you're broadcasting HD today at, let's say, minus 10 dB injection, whatnot, have a look and see if your first and second adjacent on one side are clear. Maybe that is one way to build it. Maybe you can start to move that way. Or, like I mentioned earlier, if if in essence, one of your iBox sidebands is only stepping halfway onto your first adjacent, right? Because your first sideband is from 100 to 200 kilohertz. Your next station over in another market would be at 200 kilohertz. So really, you could make the argument, if I were to reduce the power that's currently not causing any interference of one of my sidebands, let's say I'm broadcasting 100 watts right now in one of the sidebands, bring it down to 50, and move those 50 watts over 100 kilohertz. So really, there shouldn't be any other interference there either, because you're still putting the same amount of power in the other channel. So I'm thinking you could potentially do a 600 kilohertz on that, if you argue that.
Yeah,
but again,
one would have, at least in the U.S., one would have to argue that before the FCC and get some rule changes, seems to me. But Philip, I wonder if you might touch on, when I first heard of this idea, I was talking to your friend and colleague Chuck Kelly, and I said, so why would somebody want to program this many audio channels? I mean, some stations have a problem keeping up with the 2 or 3 or 4 or 5 that they do. How are they going to keep up with 15? And he said, well, what if you outsourced some of this programming to other groups and charge them to be on your station or whatever reciprocal deals you may have? What were some of your thoughts about audio programming on this kind of technology where you've got so many channels available?
Right. Well, there's actually an application right in our backyard that would explain that a little bit to you. Right here in Canada, we have what is called a class of station, what is called is ethnic stations that are required by the CRTC, the Canadian Radio, Television and Telecommunications Commission. They're required to broadcast multiple languages, up to 10 languages throughout the week. So they day part. In the morning, you might have Cantonese and Mandarin. In the afternoon, on a drive home, you might have Punjabi. On the weekend, you might have German, Icelandic, Filipino, whatever. So these stations have a mix of languages today, and they're required to do so. Because we do want to be a mirror of our society, and we have many, many cultures in Canada, many languages. But the CRTC recognizes we don't have enough frequencies for every language, so they have to day part. And as part of the license, they have to do that. So now with HD Multiplex, here comes the opportunity to give each culture group, each language, their own channel. Now, of course, you'd have to do the programming for that and whatnot, but I think you'd find enough interest in those culture groups to take that on and work with those stations to, set up the infrastructure to produce the content and put it in secondary channels, whatnot. And, the concept is already sort of proven with a few stations in Toronto that have placed dedicated languages on secondaries. So the concept works. But with HD Multiplex, you could install one of these transmitters in each market and let, some carrier, some nonpartisan carrier would lease out those channels. And, you could have all of these cultures represented accordingly. So I think that is a really neat application.
Hey, I thought of a great use for this for a small town station in the U.S. They could transmit every Little League baseball game going on in town at the same time. and not have to play favorites anymore with moms and dads as to which ball game will make it to air. They can all be on the air.
Right. Well, you're absolutely right. But, you can take that to real sports stations, too. Those games are all on at the same time. now you can schedule that out across multiple streams. So again, sports radio would certainly take advantage of that.
Hey, we have just about come to the end of our hour, guys. We're going to talk about our last sponsor, and when we come back from that, we'll have a tip from Phil, and hopefully we'll have a tip from Chris. I know Chris joined us late about something that interesting that will help you as an engineer, as an audio guy, as an RF guy with your job. With your life, just something to help you out. Our show, This Week in Radio Tech, episode 305, with Philipp Schmid from Nautel, is brought to you by the folks at Axia and the Axia Radius AOIP audio console. I love talking about this console, well, in part because I'm owner of several of them at my radio stations in American Samoa. I just had lunch today with a fantastic engineer here in the Nashville area, and he's going to be putting this console or one like it, either this or the IQ, into a new facility in Texas. And man, I had to tell him, look, I've got 2 of these consoles, and I just love these things. In fact, one of these Radius consoles is handling this very show right now. It's providing a perfect mix minus to me, to Chris Tobin, to Philipp Schmid. Even though Philipp Schmid at first was on Skype and now he's had to join us on the phone, we can get a perfect mix minus to any participant because this console, like all Axia consoles, creates a mix minus for every single input coming in that you want to. It's just an amazing console because, well, first of all, it's easy to hook up. It's audio over IP. This console, the Axia Radius, plugs right into a network with other Axia consoles, bigger ones or smaller ones. And that's really amazing. Then it also has all these features like microphone processing and EQ. It does, as I said, the automatic mix minus, automatic backfeed. So if you've got talent with headphones or an earbud like I'm wearing right now, you can feed an appropriate talkback or back feed to any talent, whether they're local in the studio or whether they're remote somewhere on a phone or on a codec. So that is a real convenience. It's so easy for the talent to use this console. They can bring up a profile and bam, have all the faders set exactly like they want. If they accidentally touch the wrong button or mess up the bus assignments or something like that, all they have to do is reload the profile. It won't interrupt what's on the air, and it'll just load the profile and fix the console to be back like it should be, which is it's a very useful thing for today's busy talent that really can't be concerned with setting up complicated mix minus busing and aux buses and things like that. I love this console, and if you use it for your station, I know you will too. Maybe you already are. It's just an awesome piece of gear. It works in association with one of 2 different mixing engines, either the Core 16 or the Core 32. By the way, we spell that QOR, the Core 16 or Core 32. They're 2 different sizes, but each one of them has mic and line inputs, line level outputs, an AES input and output, GPIO is built in, both ins and outs, and an Ethernet switch is available right there on the back of the Core 16 or the Core 32. So it'll easily connect to other consoles, to a master core switch if you need that, or to other devices like a Telos phone system. It'll plug right into that. You can feed AOIP from this console directly into, say, a Telos, an Omnia 1 audio processor. So easy, so effective. It's really just it's amazing. I love this little guy. Check it out if you would at telosalliance.com. That's the website, telosalliance.com. That is the Axia Radius console. Big LED meters, a clock built right on the front of it there. Easy peasy to use, just the right size for so many stations. I think you're going to like it. Thanks to Axia for sponsoring This Week in Radio Tech. All right, Philip, you and I talked a little bit earlier about maybe you have a tip for either Nautel customers or engineers in general on what they should be looking out for. Got something for us?
Well, I think it's a general HD tip. My background being HD, whatnot, I thought I'd do something like that. But I think the general thing is don't assume that all HD services, all multicast channels are created equal. What I mean by that is as you're building out your secondary services on HD, you start maybe with just an HD1, the simulcast of your FM, add HD2, 3, 4, and at some point you'll probably add an extra HD carriers, what's called the MP3 mode. that are carriers closer into the FM. And those ones you want to be a little bit careful with because they don't have as much forward error correction as the other carriers in the system. So the signals on that, on the audio on there, will not have the same coverage as the ones on the MP1 carriers. So as you're planning to build out your services, whatnot, make sure that you allocate whatever is sort of the least important one to those carriers.
Ah, okay. So that's called the MP3 mode when you add carriers that are closer in to the FM.
Right, exactly. So even let's say you haven't fully filled out your MP1s yet, you might already go MP3 because okay, that particular audio stream is probably going to be secondary, so we'll place it there now and just give the other channels a little bit more bandwidth for the time being until we fill it out.
Gotcha. Good tip. Man, there's so much to learn about this technology. Chris Tobin, before we wrap up quickly, have you got a tip, something that you'd like to pass along to our viewers?
Well, I've just been doing a lot of IP networking lately, and one of the things I came across was a Paisler, I think it's how you say it, Paisler network monitoring tool. It's there's a free trial for 30 days you can run with it, and it helps you to monitor your network, application servers, see what's going on, and get a better idea of the health of the network. And since we're talking Axia networks, we're talking office networks, studio networks, we're talking newsrooms, and even with the Nautel equipment and HD radio, it's all about networking. So it may be worth looking at application monitoring and say, hey, you know what, let me take a look at my network and make sure I understand what's happening. Recently worked with a couple of folks where we were noticing some issues with data transfers and was interfering with a couple of codecs we had between cities, and it turned out that the office network was spewing out broadcast packets from a device that was having trouble staying in check.
Yes, so, of course it was.
Of course, but wouldn't have discovered it if we hadn't been using a different product. It was an application monitoring tool from a different software company. So I'm just suggesting, Paisler, I think it's PAESSLER.com. And they have a free trial with no limitations, so you can check it out.
Okay.
PRTG, I think, is what you can search. Yeah, PRTG Network Monitor.
I have heard of this, and in fact, I think I checked it out once upon a time. I'll check it out again. We'll put it in the show notes. We got a Zoom. Chris Tobin, thanks for making the effort to join us. And Philipp Schmid has been our guest. Philipp, I'm sorry we lost you, but I'm so delighted that you joined us for the last few minutes by cell phone. That is awesome. Thank you very much.
All right. Well, it's a pleasure to be here.
All right, we'd like to have you back on too, and maybe we'll see you at a show or something. We can get some more interview with you and explain whatever's next for broadcasting. Thanks to Nautel for being on top of these things. I appreciate it.
All right, bye then.
All right. Hey, you've been watching This Week in Radio Tech. I'm Kirk Harnack along with Chris Tobin, and Philipp Schmid from Nautel has been our guest today. Thanks to our sponsors, and thanks also to Suncast. Boy, we kept him busy today, too, for producing This Week in Radio Tech. Next week, Chris Tobin hosts the show along with one of your favorites. It's Charlie Wooten from Panama City, Florida. He's going to be on the show, and he always gives us a big belly laugh and a lot of fun and some great information because the guy knows what he's talking about. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.